Learn ANSYS Mechanical Linear and Non-Linear Dynamics by Professor Surner. So in these slides we will learn different types of linear and non-linear dynamics behavior which is solved in ANSYS software, so that we will look for the objective. So objective is that to be able to study the dynamic behavior of structure, any structure like from your automobile vehicle to constructions like bridge, etc. To be able to select which dynamic analysis are appropriate for the results, means there are different inputs to given different types of analysis, so that we can learn by using these slides. What are the input for model analysis, what are the input for random vibration analysis? So these types of analysis are we will see in this slide. Now these are the some objective we can see here. So we will go for the next slide. Now there are different types of dynamic analysis. Firstly we will see that. So first one is a model analysis, second one is a harmonic analysis, third one is a response spectrum analysis, and fourth one is a random vibration analysis. So we will go through one by one. So firstly we will see model analysis. So these all analysis will be solved in ANSYS workbench either or ANSYS APDL. So we will see one by one what are the inputs for that, what will be the output, and why it is needed. Okay, so firstly we will see model analysis. Now why model analysis is required? Now model analysis means to calculate the natural frequency. Now what is the purpose for calculating the natural frequency? Natural frequency is calculated because we will find out natural frequency of particular component, so that the applied frequency or external applied frequency is matched. If it is matched with natural frequency, so resonance will occur there and chances of component failing is increased. Okay, to calculate natural frequency and mode shape it is required. Now by calculating natural frequency, anyone can avoid the resonance, as I already explained with the excitation frequency. For that, what are the inputs required in analysis, or you can say what will be the boundary conditions, right? Now input for the model analysis. Now simple geometry which is required, suppose bridge structure, automobile components, or whole body, you can create it in any software like CATIA, SolidWorks, Creo, Pro-E, etc. That, or you can create simple geometries in ANSYS design modeler also. Now there will not be any other input like force or other constraints. You have to just fix geometry as it is, as it applicable, okay, and give the mode, number of modes which you want to generate. For example, 9 mode shape, 10 mode shape, 16, whatever you meant. Now, and what will be the output? Output is a natural frequency of that particular component you will get. So for example, rod fixed at one end. So this is a basic example which I have given here. So next one is a harmonic analysis. Now everyone knows a harmonic wavelength or harmonic frequency. To do that in analysis it is, so why harmonic analysis is required? Now it is used to determine structure response to a steady state and harmonic loads, right? So for giving example is loads on bearing, right? That load is a harmonic load. So to calculate or to do the analysis of that, we need input of harmonic analysis, right? So So that inputs are spectrum response or response to a specific time history plot. So that can be calculated by using the experiment, and that data is used as an input for ANSYS. So after applying the boundary condition, so we can get output, that is a harmonic frequency of a particular component, right? So as already given the example, that is a loads on bearing, right? So next one is a response spectrum analysis. So this is a analysis which is very useful to what we can say, to generate the plot of earthquake response, right? Suppose there is a center of earthquake on any region, right? So you can consider if earthquake happens at that time, what will be the response on earth at that particular region, from centers to different locations. What will be the maximum response, or what will be the response to that earthquake frequency, right? Now it is used to determine how component responds at an earthquake. So that I already explained. Now what are the inputs, right? So inputs are spectrum representing the response to a specific time histories. So that data is calculated at the time of previous earthquake, and that is used as an input for the analysis. Now what is our output? Output is a maximum response of components on earth when earthquake happens, right? So by using that frequency, we can construct our homes, we can construct bridges, we can construct any structure which is present on earth. So that is a very useful for response spectrum analysis. So last one is a random vibration analysis. So it is mostly used in automobile sector. So why random vibration analysis is used, or why it is needed? So it is used to determine how component responds to a random vibrations. So I will give one simple example. So suppose one vehicle is going on road. That road is very disturbing, it is not continuous, having very rough patches. So that vibrations can be generated, but which is not a continuous vibrations, right? So it is a random vibrations. So to survive that vehicle on that road, we have to do the random vibration analysis. Now what is the input for that spectrum representing the probability of distribution of an excitation frequency? So that is a input. So that data is collected from the actual experiment which is performed on road or whatever component or you are using wherever. Okay, you can get that data from the experiment, and that data is used as a input for ANSYS. Okay, now output is a response with specific range of probabilities. So it will give the output, mode, shape, random vibration, how your component is behaving at particular random vibration input. So that will be the output. So this is the end of the presentation. Thank you very much.